Well, hello, and welcome to this video on language and authority on science. Before we begin, I have a question for you. What did the science book say to the math book? You've got problems. Get it? Because math books contain lots of... Okay, never mind. I thought it was fun. Anyway, let's move on. Talk about language and authority in science. So what are we doing here? Here's what I'm trying to help you get out of this lesson. The first thing is, after this lesson, I'm hoping you'll be able to describe scientific research using language that reflects how science is actually done. So a lot of what you get in your classes in school is not exactly the same way that science is actually done in the real world, because it's trying to present to you what science already knows. But I want to give to you the ideas about how science is actually done and give you the tools to describe it accurately. And then I also want you to be able to think a bit critically about scientific findings, who presents them, and their implications. Let's see what we mean by all this. So I'm going to start off with an example of chocolate. So a lot of people are obsessed with chocolate. Cool, makes sense. But the question seems to come up a lot, is it good for you to eat all this chocolate or not? And I think there's a lot of people out there who would love to know that eating chocolate is good for them so that they get an excuse to eat more and more of it. Okay, fine. So let's take a look at some headlines about some scientific research on chocolate. So note here what this one says: scientists prove chocolate better than being in love. Well, that is quite the claim. Here's another one: scientists prove that food like chocolate, red wine, and cheese help you live longer. Well, that would be kind of awesome if you just got to do that. And then here are 7 proven health benefits of dark chocolate. Proven health benefits. Notice the word that I am highlighting here. I'm highlighting proof, prove, or proven. Right? I'm highlighting those words. And why am I highlighting those words? Because that word actually really means something very specific that is not really part of science. So if we use this term proof, that means we are requiring absolute certainty. There is under no circumstances a possibility that it might not be right. Notice, by the way, my little take notes bitmoji over here telling you that this is something you're going to want to make sure you take notes for. Okay, so the term proof, again, requires absolute certainty. And you might find this in, say, math, right? So when you take geometry, you will prove a lot of things, because in math you can prove with absolute certainty that something is definitely true. Science never makes that assumption. Science never believes that anything is totally true. Even the things that I tell you in class, they are things that scientists believe to be the best explanation, but they are never considered 100% absolute certainty, because science operates from what we call a position of skepticism. Position of skepticism. So skepticism meaning, I am not so sure about that, right? I really need you to work really hard to convince me that whatever you're saying is true. Because science needs a lot of evidence for an idea to be changed. But it is also openness to the possibility that our current understanding may be revised, adjusted, or even overturned, right? So what that's saying is that science both says, hey, I'm not sure about this new idea, but we also know that it is possible that, given enough time and evidence, that a new idea might come along and really change what we already knew. All right, if you need to, pause the video to take some notes. Let me give you an example. So let's say it's before the 1950s, first half of the 20th century. Maybe your grandparents are in high school, and they might learn about the origins of human beings. Where did human beings evolve? So back then, the idea was called out of Asia. Still getting the hang of this thing. Out of Asia. So that idea said that somewhere around here is where human beings first evolved, and then they spread out to places like Asia and Europe and Africa, etc. But then a lot of evidence was gathered in the mid-20th century, and most of that evidence was found here. Really, a lot of it actually in the African Rift Valley, it's kind of in this area, that showed that that seems to be where the earliest human beings appeared, and that they probably left Africa and spread out across the world. And that's called the out of Africa idea. And so that's generally speaking what most people accept as the explanation now, although there are even now, questions arising about maybe they actually evolved in more than one place, or maybe the story's more complicated than we thought. So both skepticism and acceptance of the possibility we might end up overthrowing some ideas that we have. It doesn't happen that often, and with certain things it really is unlikely to happen, but it is certainly a possibility that science wants to keep in mind. So some more things to take notes on here, and let me remind you again, science never proves anything. That's not a thing that we do. We don't prove anything in science. What we do is we work to develop ideas best supported by us. So let me underline that. Ideas that are best supported by evidence. So we have evidence, and whatever idea best explains why we see what we see is where we're tending to go in science. So what we don't say support, or we don't say prove. What we say is support or not support, right? So using the example from the previous slide, if you find all of these early humans in Africa, that supports the idea that human beings evolved in Africa. It does not support the idea that human beings evolved in Asia. All right, let's now look at some examples of how we might actually phrase what we're trying to say. So let's imagine that you did a survey, you went to 50 Monarch students and said you prefer iPhone or Android, right? And you just simply recorded what they said. There's your evidence. How are you going to report it? So if, for example, more of them said iPhone versus Android, one good phrasing way to say this might be, hey, the data gathered from my survey supports the idea that Monarch students prefer iPhones over Android phones, right? Bad phrasing would be, well, I proved that Monarch students like iPhones better. First of all, we never prove anything. But second of all, you didn't actually ask every single Monarch student. You took a sample. It's possible you were wrong. It's possible that people's opinions might change. We don't ever want to say we proved something. What we want to say is we've got some evidence supporting this idea. In addition, so here's another thing that tends to really become problematic when the news reports on science. The news often makes you think that because one study, one experiment was done, that's the final word, right? So here's an example. Coffee is good for you, more science shows. And if you look at it carefully, what they actually said was there's one new report that says people are less likely to die over a 10-year period than non-coffee drinkers. That is far from the final word about whether or not coffee is good for you. And in fact, if maybe your parents are more familiar with this, the research has actually gone back and forth where there's studies that show that it's bad for you, studies that show that it's good for you, and it's really not about any one of those studies. What it's about is about the body of evidence, all of the information, all of the thinking that's gone. Because one study could be poorly done, could only apply to a certain situation, or could be intended not as the final word, but just as a contribution. So it's possible that someone just did some survey, gathered some evidence, and said, let's just take a look at this, not intending to say, hey, I have discovered exactly that, but they want to contribute to the conversation about the body of evidence. That's why we never look at one study and say that's enough to decide what exactly is going on. Okay, so authority. In terms of authority, I'm sort of trying to say, well, who gets to say what's the scientific understanding of something? Who gets to say this is what we know? So generally speaking, scientists don't rely on one experiment or study because that's not enough. That's not a body of evidence. That's one thing. So what they actually do is they examine evidence, and they challenge each other's reasoning. So I see that you said that Monarch students prefer iPhones. Why did you say that? Where did you get this data, right? They come at each other skeptically. And what they're trying to do is constantly revise and refine understanding. Revise and refine understanding. And there are formal processes for doing this where scientists will write down what they found and what they think. And then there other scientists in the same field will do something called peer review, and that's a term you should know, peer review. those like them, right, other scientists who are studying the same thing will say, I agree with you here, I don't agree with you here because of this and this reason. And in order for us to get to the big, broad explanations of things that end up in our textbooks, for example, we need support and support and support over the years. So, for example, evolution by natural selection was first proposed by Charles Darwin more than 150 years ago. But that wasn't the final word, right? He writes a book on it, but that's not the final word. What happened was a lot of people started looking for evidence to say, can we back up what he said, or do we see something else going on? How can we best explain how life got to be the way it is? And after all that time and all of that work, all of the evidence continues to point in the direction of natural selection being the best explanation for why life looks like what it does. There's been additional information that's helped refine it and add some more detail to it. But because it has stood this test of time with so many people asking questions and looking for evidence, that's why it's supported as this big explanation in biology that you'll learn about in next year's science class. So, okay, you're a student and you want to know how you can participate in this kind of thing because it sounds like, well, man, these scientists need to have peers and there's so much to know out there. How are we supposed to know that? Well, we're going to use something we call the claim evidence reasoning framework. Now, this framework, it's not a method. Again, there is no single scientific method, and this is not a method. What this is a way to help you think through what you're trying to do scientifically. So scientists do this whenever they do their work, but they don't necessarily always put all of these terms on it. We put these terms on it so you as a student can better understand what you're doing here. So what is a claim? A claim is a statement that answers a question. Statement that answers a question, right? So I claim that this is the best answer to whatever question we're trying to investigate. The evidence is whatever data we use to support that claim. So we have some information. We can all agree at least on the existence of the information. And that's what we're going to use to support the claim. And then the hardest part that most students struggle with is the reasoning, right? Sometimes I think it's because it can be actually too simple. But the reasoning is, well, why does this evidence support the claim? You have all this evidence, and then you're saying this is what that means. We want to know why you think that is, right? So that's the reasoning. Let's take a look at a quick example of how this might work. So we have a simple but testable question. Is Johnny going through puberty, right? Puberty is a period of transition in everyone's life. So we might make the claim, Johnny is going through puberty. And you see that down there. And why are we making that claim? Well, we have some evidence that we gathered, right? Our evidence says Johnny is 14 years old, right? He's grown 4 inches in 6 months, which is a lot, and his voice is getting deeper, right? It might even be cracking a little bit like this, which is uncomfortable, but happens to all of us. It's okay. So why do we think this evidence says Johnny is going through puberty? Well, the reasoning is, and again, this is the part that's sometimes not as obvious to figure out, puberty is a time when boys experience growth spurts, right? Like Johnny did, voice changes, and it usually happens in the early teenage years, right? So now we have reasoning that explains why this evidence supports the claim. Had we different evidence, we might have a different claim to make. We could actually say maybe Johnny isn't going through puberty because these things aren't true. So we're going to get more into that. We're going to do lots of examples of that, but that is a way to think about how science is really done. I hope you enjoyed that, and I will see you in the next video.